Chapter 6 of Young and Freedman's University Physics book is on work and kinetic energy. So the first section begins talking about work. Now you might remember that the unit of mass in by international standards is the kilogram, which is the amount of stuff that a certain amount of material has in some undisclosed location outside of Paris. So the unit of stuff, the unit of mass, is the kilogram. And then the unit of force, the standard unit of force, is the Newton, which is the amount of force it takes to accelerate 1 kilogram of stuff 1 meter per second square. Work, then, the unit of work is the joule, and it is the amount of work done when 1 Newton of force moves some stuff 1 meter. And so that's the joule in units of Newton meters. Now, if a force pushes something straight on, no problem. Force times displacement equals the work done. Very simple, if it's straight line kind of displacement. The complication comes when force isn't straight on, and then we have to use a little trigonometry. So for example, if the force is going at this angle and you're trying to figure out the amount of work done on something that moves at this angle, then you have to figure out what the component of this force that is pushing in this direction. And the way to do that is to multiply the hypotenuse by the cosine of this angle, because the hypotenuse times the cosine of this angle gives you this side, the adjacent side to the angle, because the cosine is the adjacent side divided by the hypotenuse. So the force times the cosine of the angle at which this force is to the displacement direction is going to give you the F cosine theta is going to give you the amount of force going in this direction, and then if you multiply it times the displacement S, then you're going to get the amount of work done on that particular direction. So work equals the dot product, as it were, of the force times the displacement.